Good morning. morning to all. Thanks for gathering here.
Hello, ma'am. Yoga Priya, ma'am.
Shall we start, ma'am? A very pleasant morning to all. Always welcome a new day with a smile on your face, love in your heart, good thoughts in your mind, and you will always have a wonderful day. So, I would like to call upon Mr. V. Karpasamy sir, Assistant Professor of IT Department, to give away the welcome address.
Very good morning to all. Respected Chairman of Konganadu Institutions, Principal of Konganadu College of Engineering and Technology, Dean R&D Madam, distinguished guests, then participants from various colleges, my dear colleagues and students. Good morning to all once again. And all present over here. While doctors, nurse, and medical officers will probably never be replaced by robots and computers. But the modern technologies, machine learning, and AI are transferring the healthcare industry. This transformation is leading to improved outcomes and changing the way to doctor think about providing care. As you all know, the current scenario of the healthcare system in India, we all have gathered here to discuss about very important topics like optimization of machine learning algorithm for better healthcare services, which is the most important issues with the significant implications for the future of healthcare services in India. Once again, I wholeheartedly welcome all the delegates for this DPT sponsored one-day seminar. Thank you all.
Thank you, sir. The most alluring thing a woman can have is confidence. I'm delighted to welcome our Dean R&D, Dr. J. Yogapriya ma'am, to give away the felicitation address.
So good morning, Randall present here. Am I audible?
Yes,
Hello.
ma'am.
So today we have gathered here for the program of Department of Biotechnology sponsored program on optimization of machine learning algorithm for better healthcare services. So first of all, I would like to thank DPT who has accepted our proposal to take the accepted our Department of IT submitted proposals. First of all, I would like to thank all the participants who have joined for this today's program. And also today's chief guest we have invited is from PSG College of Technology, Dr. T. Kartika Renuka ma'am. Then Mr. V. Chandran sir, he's a certified NVIDIA instructor for deep learning. So those who have accepted our invitation to take this today's session. So thank you, Kartika ma'am, and thank you, Chandran sir. Now I hand over the session to Chandran to talk about few minutes about this seminar.
Thank you, ma'am. It is audible, right?
Hello, Chandran sir.
Yeah, ma'am. It's
Yes,
audible.
yes, yes.
Yeah, yeah.
Ah,
Just give me 2 minutes. I will share my screen.
First, we welcome our guest speaker, Dr. V. Chandran sir, certified NVIDIA instructor for deep learning. His field of research interests in deep learning and machine learning. Software skill in Cadence, MATLAB, Python, DLS, Google, Neural Network Console. His experience as a business analyst in Grade Learning, Chennai. Assistant Professor in Department of Electronics and Communication Engineering, KPR Institute of Engineering and Technology, Coimbatore. Awards in Warden Educator Excellence Award from Warden Foundation. deep learning batch from IBM, and so on. Let me turn the time to you, sir.
Thank you so much for your kind introduction. Hope my screen is visible, right, to everyone? Hello. It's audible.
Yes, sir, audible.
Okay. So okay. So let me start with the session. Okay. So before getting into session, I will discuss about what is the advantage of learning about machine learning or deep learning or artificial intelligence. Okay. So everyone know about that the hype around the artificial intelligence has been very high in the recent years. Okay, so let me take an example of last 2 decades. Okay, the hype around the artificial intelligence has been very high. Okay, so due to three parameters, or due to three things. One is the volume of data. Okay, and the second important is that we are having some good computing powers, and then third one is that so we are in the position to able to mimic how the human brain is thinking. Okay, so these three are the primary concerns or primary advantage of being we have the hype around this artificial intelligence. Okay, so we are having some different set of methods like we have so if you get into the picture of AI, so AI is a whole umbrella. Okay, so inside that umbrella we are having some multiple fields. Okay, which is we are having a machine learning, we are having a deep learning, and we are having a digital twins, we are having the um, blockchain, and we are having the IoT. Okay, so we can integrate all these different technologies with AI to provide some useful automated software or automated tools. Okay, so uh, then when we have understanding that why machine learning. Okay, so because this machine learning has been introduced in the year of 1957 itself. Okay, so where we are having the conference name called Dartmouth conference, so they have mentioned this technology as artificial intelligence. Okay, but if you take recent years. Okay, so now only that machine learning has been evolved very quickly in last 2 decades. Okay, so in this particular session we are going to discuss especially about machine learning algorithms. Okay, and what are the different types of algorithms we are having with respect to machine learning. Okay, so if you have any doubts before getting into session, so you can ask, otherwise I can go ahead. Okay, so if you have any doubts in between the sessions, so please make yourself unmute yourself and you can ask your questions. Okay. Okay, so all the materials that has been available in GitHub itself. Okay, so after the session, I will share the link with you. Okay. So first, introduction about the machine learning. Okay, so machine learning is making a great strides. Okay, so I already discussed about it, right? So the three big bang theory for the recent development in machine learning is, one is large and good data sets, that is the volume of data, and then compute power. We have good compute power and the processing algorithms. Okay, so these three are the primary key items to get a good evaluation in the machine learning algorithms. Okay, and we have many interesting applications with respect to both commercial and scientific. Okay, so we'll get into discuss about how the industry will publish the papers. Okay, but as a industry, as a commercial part, how we can make any machine learning products, okay, to do some usefulness, to provide some usefulness to the society. Okay, so let me discuss later about what are the commercial and scientific applications of machine learning. Okay, so links with artificial intelligence. However, the AI is not equal to machine learning. Okay, I already said that. Okay, so AI is a big picture. Okay, it is a big umbrella. Okay, so inside that umbrella only we are having these different technologies called machine learning, deep learning, like that. Okay, so with respect to task, we are going to categorize the machine learning algorithm into three types. Okay, one is a supervised learning, and then next one is unsupervised learning, and third one is a reinforcement learning. Okay, so I hope most of you are aware about supervised and unsupervised. Okay, so supervised nothing but whenever we have the data with a labeled or with a labeled column. Okay, so then we can define that as supervised learning. Okay, so one of the example of supervised learning is regression. Okay, so can anyone say what do you mean by regression? Because most of you study the mathematics, right? Okay, so can anyone say what do you mean by regression? Any idea? Anyone from the audience? So I already display the output also, the answer also. Okay, so regression is nothing but predicting the real values or numerical values. Okay, that is what it's called regression. Okay, so let us take an example. First, we will discuss about the supervised learning. Okay, so the supervised learning, we already said the data with label. Okay, so let us take an example. I have the features like this: x1, x2, x3, and x4. Okay, and I have the output. Okay, so let us take an example. Okay, so I have features like 2.5, 3, 4, and 6. Okay, if this 4, so these 4 are the features, then I will tell, okay, my output would be 12. Okay, so we will what we are going to do is, so we are going to calculate the relationship between this x1, x2, x3, x4 with respect to this output. Okay, so the final equation would be like y equal to b naught plus w1 x1 plus w2 x2 plus w3 x3 plus w4 x4. Okay, so we are going to find this b naught and this w1, w2, w3, w4 in order to find the relationship of the y, that is output, with respect to the inputs. Okay, so in general this equation can be written as y equal to summation of I equal to 0 to n wi xi. Let me take instead of having 0 we can mention 1. Okay, so plus b naught. Okay, so can anyone say, have anyone seen of these equations, which is can anyone say which this equation is similar to which equation? Anyone?
Hello, sir.
Yeah.
Sir, good morning, sir. Sir, we can't see your slides, sir. So whatever writing is not visible to us.
Now it's visible to everyone.
Yes, sir. Now we
Yes,
can
sir,
see, sir.
visible.
Yeah, thank you. So
Thank
thanks
you,
for
sir.
letting me know. Okay, so can anyone say this y equal to summation of y equal to 1 to n wi xi plus b naught? Okay, so can anyone say this equation which is similar to what equation? This particular
Slope,
equation.
sir.
Slope. Okay, what is in general it is called? Okay, so this equation which is similar to y equal to mx plus c. Okay, so what is that y equal to mx plus c?
Straight line equation.
Yeah, so this is the equation of straight line. Okay, so this is the basic fundamental about machine learning algorithms. Okay, so we are going to find the straight line in such a way that it is capable of predicting the real values and also do some classification part. Okay, so we have seen about regression. Okay, so this whatever the example we have seen, which is equal to a regression. Okay, so let me give this is x and this is y. Okay, so I randomly plotting some values. Okay, so let us check y. This is price of the sorry. Otherwise, it is called a number of bedrooms in a house and y equal to price. Okay, so our task is to find the price of the house with respect to the number of bedrooms. Okay, in a building, in a house. Okay, so what I will do is I will try to plot the line. Okay, so I want to plot the line where it is touching most of the points. Okay, so let us take an example. If I plot like this, okay, so this way I will do one thing. Otherwise, I will draw a line like this one line. Okay, otherwise I will also draw a line with respect to this, and also I will draw like this, because there is a no such a way that we can able to touch all the points. Okay, so for each and every line we have to calculate the error. Okay, so we have 4 lines and we have to calculate the error for the all the 4 lines. Okay, so then we have to decide the line which has a minimum error. Okay, so that's how this regression algorithm will work. Okay, so for doing the regression algorithm, we are having a two parts. One is called two methods. One is called OLS method. Okay, and then we are having the gradient descent method. Okay, so the OLS method is nothing but it is called ordinary, so least square method. Okay, so which is traditionally used method. Okay, and then we have gradient descent. Okay, so because we are going to find this W and B, okay, which is called this W is called weights, W is called weights, and B is called bias. Okay, so these two parameters will be computed with the help of so this gradient descent algorithm, and also we have the OLS method. Okay, so these are the two methods we are having to find the regression part. Okay, so any doubt up to this, up to regression level? So we'll discuss about some hands-on in the afternoon session. But if you have any doubts with respect to theoretical concepts, so just unmute yourself. You can ask. Any doubts? Is everyone clear about the concept of regression? Okay. So if there is no doubts, I can go to the second part, which is called classification algorithm. Okay. Okay, so the classification is slightly differ with respect to regression. Okay, so we will have x1, x2, x3, x4. Okay, so instead of having the real number, we will have some classes. Okay, like let us take the same example: x1, x2, x4, 2.5, 3, 4, 6, and then output. Okay, so the output would be like class 0, class 1, like we can mention there is 0, 1, 2, 3, 4, like that. Okay, so otherwise we will have yes or no. Okay, so please have this clear idea. So whenever it is a classification, then we have the labeled which is a categorical value. Okay, so whatever we are getting in the output of the regression, it is a numerical value or any real number, but whenever we are using the classification part, so we have to use the categorical variable. Okay, so this is the two primary difference between the classification algorithm and regression algorithm. Okay, so let me take another example for okay, so classification. Okay, so same, I'm going to plot x and y. Okay, so here I'm going to have tumor size and cancer. Okay, so I'm going to decide with respect to the tumor size, the what would I say? The probability of having the cancer is very high. Okay, so let us take an example. This is an example. Okay, so if I want to classify these two things apart, okay, so what I will do? Okay, I want to categorize these two things. Okay, so one is a cancer, and then next class is a no cancer. Okay, how can I do that? Any idea? Any idea? Can anyone say? Any idea, guys? Okay. So let me get into that thing. Okay. So here also what we can do is, sorry, excuse me. What we can do is, we can draw the line like this. Okay. So we can draw the line like this, and we can say, so what are the data points that has fall above this line? We can define that as a cancer, because you know that the tumor cell is directly proportional to cancer. Okay, and then the data points whatever falling below this line, we can name that as a no cancer. Okay, so this is how the classification algorithm will work. Okay, and we with respect to how like so we have the term called loss function. Okay, so for regression we have to use a different loss, and for classification we have to use the different loss. Okay. Okay, so with respect to loss function for regression, we are having a MSE, that is called mean square error, and then we are having a mean absolute error, and okay, and then we are having a who is presenting this screen? Who is Kausalya? Kausalya from Aeronautical Department. So can you please share your screen? Guys, will my screen visible? Is it visible now?
Yes, sir.
Yes, sir.
Yes, sir.
So please let me know if someone is sharing the screen. Okay. Okay. So we are having a MSE which is called mean square error. We have MAE which is a mean absolute error, and we are having a RMSE value. Okay, so mostly the MAE and mean square error has been used for the loss functions. Okay, with respect to classification, we are having a binary Guys, I am audible to everyone.
Yes, sir. Audible.
And also my screen is visible, right?
Yes, sir.
Yeah. So with respect to classification, we are having a binary cross entropy, and then we are having a categorical cross entropy, and then we are having a hinge loss. So we are having a different loss function for the classification also. Okay, so this is the way we need to define a supervised learning. Okay, so any doubt up to this? Okay, if there is no doubts, I can just move to the next slide. So So these are the very, very important concepts to understand. Okay, so if you are having a clear idea about that, then understanding the deep learning algorithm very much easier. Okay. So the next is called unsupervised learning. Okay, so this is quite different when compared to supervised learning. Okay, so we know in supervised learning we need to have the data labeled, but with respect to unsupervised learning there is a no need to have the data labeled. Okay, so one of the type of unsupervised learning is the clustering algorithm. Okay, let us take an example. I have two products. Okay, so one is a shoe and product is for mobile phone. Okay, so the feature the data set I'm having is x1, x2, x3, x4. Okay, so we are having the features like 2, 4, 2.5, 4, 2, 1. Okay, and then 7, 8, 6.5 and 5. Okay, so we know that this x1, x2, x3, x4 and for these two particular column, this two particular row will have a different meaning. Okay, so the distance between the two features is very high. Okay, so in clustering algorithm what we will do is we will try to group the features into different sets. Okay, so let us take an example. If I plot this particular thing in the graph, okay, so like x and y. Okay, okay, let us take an example. My data point is like look like this. Okay, so we have plot the in features. Okay, if we want to do the clustering, then what we need to do is we will find a okay, so what we will do is we will try to group these features into two classes. Okay, so like I will group this one like this. Okay, this is our one group and this one is the another group. Okay, so this is how the clustering algorithm will work. Okay, so any doubt with respect to clustering algorithm? Any doubts? Okay. Just give me 1 second, guys. Okay, so with respect to unsupervised learning, okay, sorry, there is some internet issue. Okay, that has been sorted out now. So with respect to clustering, we are having with respect to unsupervised, we are having clustering, and then we will have the association. Okay, so what do you mean by association? So association, I think, but find the frequent co-occurrences. Whenever there is the cancer is happening inside the body, so the cancer is directly influence our blood cells, and we will get a blood vomiting. Okay, so if any of the client or anyone have approached you and asked you to find the so then we can decide, okay, so whenever there is cancer is detected, so then there is a high probability of the patients will have the blood vomiting. Okay, so this is finding the frequent co-occurrences. Okay, so this is one of the associations, one of the algorithm which has been used in most of the retail platforms like Amazon, Flipkart, like that. Okay, and then is a link prediction, that is discover the relationship in data. Okay, let us take an example. If there are okay, so there are two data points like this. Okay, so if you find out the relationship between these two data points, okay, or if you want to find out the pattern, okay, find out the pattern how these two data points are more inclined together, then we will make use of this unsupervised learning algorithm to decide that. Okay, so that is another advantage of using the unsupervised learning, and also for doing the data reduction. Okay, so some of the data reduction algorithm we are having a PCA, TSNE. Okay, so these are some of the data reduction algorithm we are having to reduce the number of features. Okay, so the advantage of reducing the number of features is to the advantage of using the reduce the number of features is to find to build the model, to build the machine learning model in such a way that it will take some low computation time. Okay, so that is the use of data reduction in unsupervised learning. Okay, and third and final learning algorithm, which is called a reinforcement learning. Okay, so most of you are aware about supervised and unsupervised, but reinforcement learning is a different paradigm. Okay, so anyone know about a reinforcement learning in the group? What do you mean by reinforcement learning? Any idea? What do you mean by reinforcement learning? So how many of them have watched the video of Boston Dynamics in YouTube? Any idea, guys? If you have any anything in your mind, please let us know. Yeah, there is one answer from learning by good or bad. Okay, that's good. What about the others? So here the reinforcement learning, what it will do is, so it will try to learn on its own by using the reward system. Okay, so the reward may be both good or bad. Okay, so by using this two, by using the reward system, the algorithm will try to learn on their own. Okay, let us take an example. The candidate is riding the bicycle. Okay, so if he's riding the bicycle and then suddenly they have a speed breaker. Okay, but once this candidate reach the speed breaker, so due to the overspeed and also not able to apply the brake, yes, fell down. Okay, So what we will do is we will try to provide the feedback. Okay, that is a reward. Okay, what is the reward we will get? Okay, so we will either laugh at him and we will tell, okay, no, this is not the way we have to drive the bicycle. Whenever there is a speed breaker, you have to apply the brake and also you have to control the speed. Okay, so then this person will understand, okay, so this is the problem. So this is a problem. Okay, so if you want to mitigate this problem, I have to follow these steps. Okay, so this way we will try to develop the reinforcement learning algorithm in such a way that it is capable of learning on their own. Okay, so this is called a reinforcement learning. Okay, so we have covered about all the classification of machine learning algorithms. Okay, so if you have any doubts, I can give you 2 minutes of time. Okay, if you have any doubts, you can raise your questions. I'm very much happy to answer that. Any answers? Any questions? Yeah, that's good. Training method based on the reward. Decide behaviors and punish. Yes, so we are having some different algorithm for that. Okay, like policy learning, Q learning. We are having some different reinforcement learning algorithms to train the algorithm. So any other questions from audience? Okay, so there is no questions. I can go ahead. Okay, so one of the application of regression is colorize the black and white images automatically. And then this is the classification part where we are having a single image contains a dog and ad. Okay, so these are the example of classification. And then reinforcement learning, the most of the video games, whatever we have seen in the mobile phone, that is based on the reinforcement learning only. Okay, and then clustering, that grouping this crime prediction with respect using the k-means clustering algorithm with respect to the different cities. Okay, so this is another example of clustering, and this is an example of association. Okay, so like machine learning, if you want to find a application of machine learning, you can find application of machine learning in biology, application of machine learning in earth observation, recent application of machine learning in medicinal industry, chemistry, machine learning for molecular and material science. So we are having n number of applications with respect to machine learning algorithms. Okay, with respect to different sectors. Okay, and then if you take machine learning algorithm, we are having, with respect to regression, we are having a different algorithms like ridge regression, support vector machine, random forest, multi-layer neural network, deep neural networks. Okay, and with respect to classification, also we are having a naive-based support vector machine. You can see that some of the algorithm will be repeating in both the regression and classification. Is that it is showing that that particular algorithm will be useful for both the regression and classification part. By it will be triggered to have a focus a regression and classification algorithm by doing some parameters, changing some parameters. Okay, so naive-based, support vector machine, random forest, multi-layer neural network, and deep neural networks. And if you take clustering, we are having a k-means clustering, hierarchical clusterings. Okay, so what are the issues with the machine learning? Okay, so many machine learning algorithms or AI projects will fail. Okay, so the Gartner has claims that 85% of the machine learning algorithms are AI projects is failed. Okay, so this is the issue what we are really facing in the IT industries. Okay, so everyone, those who are studying about the machine learning, okay, what they have thought is, okay, so if you build the model with the data set, whatever data set we are having, then that has been done. Okay, but it is not in, that is not true in the real case. Okay, so even though if you are having the data, okay, so we need to find the data, relevant data to build the machine learning algorithm. Okay, so this is very much important with respect to in a commercial part. Okay, I'm not talking about the scientific part, but with respect to commercial part, uh, on the day one of your employment, okay, if you directly go and build a machine learning model, definitely the project will fail. Okay, try to understand that not building the model, machine learning model is not only the work of any data scientist, any ML engineers. Okay, so we have to do some data manipulation, we have to do some data pre-processing to develop the machine learning projects. Okay, so that is very much important. And then ethics. Okay, so this is another sector, or this is another diverse area. Okay, this is another diverse area which is called AI ethics. Okay, so Amazon has had subpar employees fired by an AI automatically. Okay, so they have developed the system. Okay, performance of the employees. Okay, but due to this AI ethics issue, the Amazon software has been fired. Some of the employees, those who are having subpar. Okay, subpar is nothing but they are not up to the level, but they are performing. Okay, they are all, so this system will automatically fire that employees. Okay, that is another scenario.
ஆக்சுவலா எனக்கு இந்த ஒரு
So can you see which is the last slide you have seen before my network problem? I completed scikit-learn, right?
Yes, sir.
Yeah. So next is a Keras. So Keras is a deep learning framework, okay, which is also called high-level API. Okay, if you want to develop any deep learning algorithms like RNN, CNN, LSTM, GRU, GAN, autoencoders, then we have to use the Keras library. Okay. If you are using the Keras, so Keras will run as a front end, TensorFlow as the back end. Okay, so the different layers we are having with respect to Keras, like dense, convolutional, pooling, embedding, recurrent, activation. Okay, and then the data science pipeline. So this is very much important. Okay, so from the data ingestion, like the data may be a CSV file, JSON file, XML, HF files, RMDBMS, NoSQL, HTTP. Okay, so this is how we get the data. Okay, so then after we are getting the data, the next step is to performing the data cleaning. Okay, so data cleaning, we are removing the outliers or removing the invalid values, like using the any filter methods. Okay, and then missing value. Okay, if we are having any missing value in the data set, we can do the imputations. Okay, by using the imputation technique, we will try to mitigate the problem of missing value. And then we are having the data transformation, like either scaling or normalizing the data. Okay, we will discuss about what is scaling and normalization in the afternoon session. Okay, so we have to done this must be done systematically. Okay, so if for the data ingestion, if you are directly going for data transformation, that will not work. Okay, so it is like it is a step-by-step pipeline or step-by-step process we have to follow to build the better machine learning model. Okay, and then selecting the model. Okay, so we have to select the right model. Okay, it may be a machine learning model with respect to random forest or deep neural networks. Okay, and then we have to train the model with determine the parameters. Okay, for each and every algorithms we are having a different parameters, so we have to make sure that we are passing the right right parameters for the models in order to have the better performance. Okay, and then data input. Okay, with respect to data input, we have the training data and validation data. We have to pass the right data to the model. Okay, so that is another scenario. Okay, so the training data is used to determine the model parameters. Okay, the model parameters is nothing but the weights and bias. Okay, and your validation data will try to mitigate the problem of overfitting. Okay, so this is the another point where we are having. So we have the data set, but the data set has to be split into training data and validation data. Okay, so this is another important scenario with respect to machine learning algorithms. Okay, so like we have the problem called overfitting, underfitting, and then best fit point. Okay, so can anyone say what do you mean by overfitting? Any idea about what is overfitting? Okay, so overfitting is nothing but so if the model is biased towards your training data. Okay, so you can see it is touching all the data points correctly. Okay, so if it is a scenario, then we will define as a overfitting. That is, the model is more fitted towards the training data. Okay, so that is a problem called overfitting. And then we have the underfitting problem. That is, the model is doesn't train well on your training data. That resembles the underfitting problem. And okay, so this is the point. Okay, so this is the area which is called optimum or best fit point. We have to find in such a way that the model is performing well on both the training data and also the validation data. Okay, and then the last step is model testing. Okay, so we have the data, that is the input plus output, and we have to pass the testing data to find the final score of the model. Okay, and then the final step is production. Okay, so once the model has been tested, then we have to make the model productize. Okay, like we can go with any web-based application or mobile application, or it may be a standalone applications. Okay, or you can deploy the model in any edge devices like what I say, like Raspberry Pi, FPGAs, or it may be NVIDIA Jetson NanoKit. Okay. Okay. So any doubt with respect to this? So what is the difference between overfitting and underfitting? Yeah. So if whatever the model you're trained, okay. So if that particular model is more biased towards your training data, okay. So that is the model is well trained on your training data, but doesn't perform well on your validation data. Okay. So then it is called a overfitting problem. So that is an underfitting problem, overfitting problem. Okay. If the model is not performed well on both the training and validation data, then it is called a underfitting problem. Okay, so you have to design the model in such a way that it is not having the problem of both the underfitting and overfitting. Okay, so these are the two scenarios we have to very much careful while designing the model. Okay. Okay, so any doubt, guys? So how to overcome this? Yeah, so we are having the different techniques to overcome the problem of both overfitting and underfitting. Okay, if we want to overcome the problem of overfitting, then we have to use a ridge regression or lasso regression. Otherwise, you can use a dropout technique. Okay, so if you want to mitigate the problem of underfitting, we have to increase the data set. Okay, otherwise, and we have to increase the model complexity. Okay, so there are different steps we are having, but we need to try to find which is the optimal technique to solve this particular overfitting and underfitting problem. Okay. Okay, any other doubts? Okay. So then we have around another 40, 30, 35 odd minutes. Okay. So this is a very much important stage. Okay, where we are going to discuss about the different machine learning algorithms. Okay. So before getting into this, I want some of the answers from your audience side. Okay, can anyone give the examples of any machine learning algorithms? Okay, what are the machine learning algorithms you have know? So please text your answer in the chat box. Okay, what are the different machine learning algorithms you know? I'll give you 2 minutes of time. Please post your answer in the chat box. Decision making. Okay, yeah. So we are having a linear regression, support vector machine, decision tree, SPM. Yeah, clustering. Okay, that's good. That's great. Random forest. Yeah, that's great. Okay, so these are the different machine learning algorithms we are having, starting with the linear regression, and then we are having the logistic regression, decision tree, support vector machine, naive Bayes. KNN stands for K nearest neighbor, K means clustering, random forest algorithm, and we are having the dimensionality reduction algorithm like PCA, TSNE. And with respect to gradient boosting algorithm, we are having GBM, XGBoost, light gradient boosting, and cat boost. Okay. So first we will discuss about a linear regression algorithm. Okay. So if you want to estimate the real values like cost of the houses, number of calls, and total sales over the past month, etc. Okay, so these particular scenarios are based on the continuous variable. Okay, so here we try to establish the relationship between the independent and dependent variables by fitting a best fit line. Okay, so the best fit line is known as the regression line, and it has been represented by the linear equation of y equal to ax plus b. Okay, so we can call this also, so it is similar to what we are writing, y equal to wx plus b. Okay, so can anyone say why it is called linear? Why it is called linear? Tell me guys, why it is called linear? Okay, okay, so why it is called linear is called, if you look this particular equation, okay, what are the things we are having? Okay, so we are having so we are having a multiplication and addition. Okay, so that's why it is called linear. Okay, there is a no non-linear function in the equation. Okay, so this is an example of linear regression. Okay, then we have logistic regression, which is also called a classification algorithm. Okay, so before getting into this, can anyone say why it is called logistic regression? We know that a regression is useful for predicting the real numbers, right? Then we are telling this as a classification. By why it is called a regression? Okay, why in the name it is having a logistic regression? Any idea, guys? Any hint or any points? Okay, so here also what we are trying to do is we are trying to find the line. Okay, we are trying to find the line which is categorizing both the data points. Okay, so line is called a linear regression. It is called a regression line also. Okay, here also we are going to find the straight line. Okay, so don't get confused by its name. It is a classification, not a regression algorithm. Okay, so it is used to estimate a discrete values, that is like binary values like 0 or 1, yes or no, true or false, based on the given set of independent variables. Okay, in simple words, it's predict the probability of an occurrence, of an event by fitting the data to the sigmoid function. So hence it is also known as a logistic regression, since it predicts the probability and it outputs the values between 0 to 1. Okay, so please be clear in mind, this logistic regression will be only used for the binary classification, either 0 or 1, yes or no, true or false, like that. Okay, but if you want to go for a multi-class problem where we are having a yes, no, neutral, like that, that is a 3-class problem, right? Then we have to decide, we can have the technique called 1 versus 1, 1 versus all. Okay, so like we can take first yes or no, and we also take yes or neutral, and then we will have no or neutral. Okay, so otherwise you can take another scenario, like we will take yes first, and we will have no or neutral. Okay, then you can take no, yes or neutral, and then also you can take first neutral as a one class, and yes or no is another class. Okay, so this is the approaches we are having to convert a binary classification to the multi-class classification problem. Okay, and third algorithm is the decision tree algorithm. Okay, this is one of the most famous algorithm with respect to both the academia and also industry. Okay, so it is a type of supervised learning algorithm that is mostly used for classification problems. Okay, so surprisingly, it works both well. It works for both categorical and continuous dependent variables. Okay, so it is in this algorithm we split the population into two or more homogeneous sets. Okay, so this is done by most of the significant attributes independent variables to make the distinct group as possible. For it, so I will also add the links where you can have the clear understanding of all the algorithms. Okay, I will also share these slides. Okay, so okay, what do you mean by decision tree? Why it is called a tree? Any idea, guys? Why it is called a tree? So this is the fundamental block for all the tree-based algorithm. Okay. So the structure of decision tree would be like, so this is a parent node and these two are the child node. Okay, like will play cricket. Okay, this is a question. Okay, this is yes and this is no. Okay, if you want to play cricket, then we have number of players. If number of players more than 18, we can play cricket. If the number of, sorry, it may be 22, right? 22. If the number of players less than, so it is greater than or equal to 20, otherwise we can have this as a 22. Okay, if the number of players is equal to 22, then we will play cricket. And in this scenario, if the number of players is less than 22, we are not supposed to play cricket. And next condition is that we will check what is the weather. Okay, if it is sunny, we can play cricket. If it is raining outside, we can't play cricket. Okay, so this is the way we need to create, we need to develop the decision tree. Okay, so this decision tree creation will be done by different algorithms. Okay, so inside the decision tree also we are having different algorithms. Okay, so otherwise we can call different methods like ID3 COT algorithm, like that. Okay, so but this decision trees mostly depends upon either you can find the root node using the entropy or information gain, otherwise entropy or information, and then we are having a Gini impurity. Okay, so with the help of these two techniques we can try to find the root node and also we can derive the entire decision tree. Okay, our next algorithm is called support vector machine. Okay, so it is a classification method. In this algorithm we plot each data point or each data item as a point in the n-dimensional space where n is the number of features you have, with the value of each features being value of a particular coordinate. Okay, so for example, if we only add two features like height and air length of individuals, we would first plot these two variables in two-dimensional space and where each point has two coordinates. Okay, so these coordinates are also known as support vectors. Okay, so most probably the support vector machines will be useful for any high dimensional data. Okay, like image. Okay, we have image, video, signal, or audio. Okay. Okay. Can anyone say what is the dimension of image? What is the dimension of the image?
2 dimensions, sir.
Yeah. So it is a two-dimensional data. What about the video? What about the video? I didn't want the exact answer. Please try to answer that. Okay, so video is a three-dimensional data. Okay, so signal, it may be 1D signal or 2D also, depends upon the scenario. Okay, so if you want to work with this type of data set, then definitely working with the logistic regression or linear regression or decision tree will not be that much good. Okay, so for that type of scenario, we will use a support vector mission where we try to plot all the data points in the higher dimension. Okay, so that is the advantage of support vector mission. And then is a naive Bayes algorithm. So naive Bayes is it is also another classification algorithm, which is the basic principle of the naive Bayes is works on the Bayes theorem. Okay, so it is a classification techniques based on the Bayes theorem with an assumption of independence between all the predictors. Okay, that is all the features. In simple terms, a naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other features. Okay, so for example, a fruit may be considered to be an apple if it is red, round, and about 3 inches in diameter, even if these features depends upon each other or upon the existence of the other features. But a naive Bayes classifier would consider all these properties to independently to contribute to the probability of that this is a fruit, this fruit is an apple. Okay, so the naive Bayes algorithm is mostly used in a text classification. Okay, so one of the best example is your I hope most of them are using the Gmail, right? Okay, so can anyone say how that what are the incoming emails we are getting that has been considered, that has been put into the inbox folder and spam folder? Okay, we are having two folders. Okay, one is the inbox and the spam. Okay, so whatever the incoming mails we are getting, whether it will go to the inbox folder, otherwise it is go to the spam folder. Okay, can anyone say what is the principle behind that? Any answers?
Sir, if the mail contains the subject, means it will move into inbox box, sir. If the
Okay.
subject is not present in the mail, then it will move to spam box, sir.
Okay. Okay, let us check this one of the scenario. Okay, what about the other options?
If a certain mail is reported by the users, it's not official, or it
Okay.
its motive is spam.
Okay.
It is put into
But
the
some
spam
of the
set.
mails what yeah. So but some of the mails will directly getting into that spam folder, right? Even before we are not providing it is just a spam email.
Yes, sir.
Yeah. Any idea? Okay. So what, how it is working is that it is working on the principle of naive Bayes. Okay. So what it will do is we are having some set of words. Okay. So which is similar to like free lottery or you have won the prize message like that. Okay. So this will consider to be a spam email. Okay. So this will be considered to be a spam email with respect to so with respect to this, the Google has been developed some certain set of words. So whenever the mail contains that particular word in your email, then it will be considered as a spam email. Okay. But the backbone is your naive-Bayes algorithm. Okay. So that's why the naive-Bayes is very much useful for a text classification, where it doesn't work well with the dependent data. Okay. And then is a KNN algorithm, which is also known as K nearest neighbor. Yes, okay. So it can be used for both the classification and regression problems. Okay. However, it is a more widely used in classification problem in the industries. Okay. So K nearest neighbor is a simple algorithm that stores all the available cases and classifies the new cases by a majority vote of its K neighbors. Okay. So the KN algorithm will also called a lazy learning. Okay, because there is no learning will happen with respect to K nearest neighbor. Okay. So the case being assigned to the class is most common among its K nearest neighbor measures. Okay, let us take an example. I have the data points like this. Okay. So this is the new data point. So what this K nearest neighbor will try to find is, it will try to find all the K nearest neighbor to these points. Okay. Okay, so if you find the distance between this, you can find, so this data points are 4 neighbors, right? And this one is having only 3 neighbors. Okay, so then this particular class will be categorized, will be fall into this particular class. Let us take it as a class 0 and class 1. So this point, which is 4 neighbors from class 0 and 3 neighbors from class 1. Okay, so then this point will be categorized or will be classified into class 0. So this is how the K nearest neighbor will work. Okay, so the different distance metrics we are having are Euclidean distance, Manhattan distance, Minkowski distance, and Hamming distance. Okay, so the first 3 functions are used for continuous functions. Okay, like Euclidean, Manhattan, and Minkowski functions are useful for a continuous function. Okay, but the 4th one is used for the categorical variables. If k equal to 1, then the case is simply assigned to class of its nearest neighbor. Okay, so at times choosing the k turns out to be challenging. Okay, we have to find the optimal number of k. Okay, so for finding the k, we are having different techniques like we have the salute score, and we are having the elbow method like that to find the k values. Okay, and then it is called the k-means clustering algorithm. Okay, so k-means clustering is nothing but it is a type of unsupervised learning, okay, which solves the clustering problem. Okay, so its procedure follows a simple and easy way to classify a given data set through a certain number of clusters. Okay, so this also works similar to the KNN algorithm, but here we don't have any labeled data. It will work with the unlabeled data. Okay. And then a random forest algorithm. Okay, I already said that if you have the very well knowledge on decision tree, then building the random forest that much easy. Okay, so the random forest is a the name itself is called the random forest, right? We will have some n number of decision trees, which is known as a random forest. We will have some 100 number of decision trees. If you have 100 number of decision trees put together, then we define as a random forest. Okay, so random forest is a trademark term of ensemble of decision trees. Okay, in random forest we have the collection of decision trees, which is known as a forest. Okay, so if you want to classify the new attributes for classification, we will go for a majority voting, And if you are choosing this same random forest for the regression, we will go for the average value. Okay, this is how the random forest algorithm will work. And then dimensionality reduction algorithm. Okay, so in the last 4 to 5 years, there has been exponential increase in the data capturing at every possible stages. Okay, corporate, government agencies, research organizations are not only coming with the new sources, but also they are capturing the data in great detail. So for example, the e-commerce company are capturing more details about the customer, like demographics, web crawling history, and what they like or dislike, purchase history, feedback, and many others to give them the personalized attention or personalized recommendation more than your nearest grocery shopkeeper. Okay, so as a data scientist, the data we are offered also consists of many features. So this sounds good for building a good robust model, but there is a challenge. Okay, so we have to find the features which are most highly significant, providing highly significant values to the algorithm. Okay, so like decision tree, random forest, PCA, factor analysis. Okay, so we have to find the most relevant or more correlated features to build the most robust algorithms. Okay, okay, and then last and foremost important algorithms are gradient boosting algorithms. Okay, with respect to gradient boosting, we are having a different types of algorithm. So first is called GBM, okay, which is called gradient boosting method. So gradient boosting is a boosting algorithm used when we deal with plenty of data. Okay, so to make a prediction with high prediction power. So boosting is actually an ensemble of learning algorithm which combines the prediction of several base estimators in order to improve the robustness over the single estimator. Okay, so it will train such a way that like this is a decision tree one. Okay, so first we will build the model that we will train the data set with for this particular decision tree, and from this decision tree we will take all the weak learners. We'll try to put that weak learners into decision tree 2, and again we will take all the weak learners from decision tree 2 to decision tree 3. Okay, so this will train in a sequential manner. Okay, the ultimate aim of the boosting algorithm is that we need to convert all the weak learners into the strong learners. Okay, so you can see this point. So it combines all the multiple weak or average predictors to build the strong predictor. Okay, so this boosting algorithm always works well with most of the data science competition that has been conducted by Kaggle, Analytics Vidya Hackathon, Crowd Analytics, like that. Okay, and next algorithm is XGBoost algorithm. It is another classical gradient boosting algorithm that is known to be decisive choice between the winning and losing in some Kaggle competition. Okay, so the XGBoost has immensely high predictive power, which makes its best choice for accuracy in events, as it possesses both linear model and tree learning algorithm. Okay, so making the algorithm almost 10x faster when compared to the existing gradient boosting techniques. Okay. Okay, then it's a light GBM. Okay, light GBM is a gradient boosting framework that is a tree-based learning algorithm. Okay, so all are the boosting technique only, but we are having different names, but with respect to different architecture, different predicting power. Okay, so it is designed to distribute and efficient with the following advantage. Okay, so we are having the faster training time or training speed and higher efficiency, and we have lower memory usage, and we have better accuracy, and then we have a parallel and GPU learning supported, and on fifth one is capable of handling the large scale data. The framework is a fast and high performance gradient boosting, one based on the decision tree algorithm used for ranking, classification, many other machine learning tasks. Okay, so it was developed under the distributed machine learning toolkit project of Microsoft. This LG right BGM has been developed by the Microsoft. Okay, and then final algorithm is called CatBoost algorithm. Okay, so CatBoost is recently open source machine learning algorithm from Yandex. Okay, it can easily integrate with the deep learning frameworks like Google's TensorFlow and the Apple's Core ML. The best part about the CatBoost is it doesn't require any extensive data training like other ML models, and it can work on variety of data formats. And it is not only not undermining how robust it can be. Okay, So with respect to the predicting power, with respect to the algorithm setup, all these gradient boosting methods will be differ. Okay. So these are the different types of machine learning algorithm we are having. Okay. So if you are having any doubts with respect to machine learning algorithm, you can ask. Okay. Now the forum is open for questions. If you have any questions, you can ask.
Sir, catastrophic algorithm.
What algorithm?
Catastrophic.
Can you please repeat the name? Catastrophic. Whether it is a machine learning algorithm, this is the first time I'm hearing about that. Any other doubts? Okay. So if there is no doubts, we can wind up the session. Okay. If you have any doubts, you can unmute yourself. You can ask. So there is one question from Vijay Lakshmi. What is mean by hyperparameter tuning? Yeah. So the hyperparameter tuning is nothing but so if you want to control the parameters like weights and bias, okay, so we have to control the weights and bias is have direct relationship with most of the model parameters. Okay, so we need to find that model parameters in such a way that it is providing the optimal solution to weights and bias. Okay, so if you want to tune the model parameters, then it is called hyperparameters. Okay, the hyperparameters is directly affects your model performance. Okay, so if you want to get the good weights and bias parameter, then we have to do the hyperparameter tuning. Okay, if you take random forest, the number of trees or so number of trees and dividing the data set into data splitting. So there is a different hyperparameter tuning like we are having. If you take a deep learning algorithm, we are having a dropout and we are having a number of layers, number of neurons. Okay, and what are different activation functions. Okay, so we are having different hyperparameters to tune like learning rate, epoch, batch size, like that. Okay.
Thank you for joining with us, sir.
Yeah.
Thank you, sir.
Thank you, everyone.
Okay.
A little progress each day adds up to big result. Once again, I would like to welcome our chief guest speaker, Dr. D. Kartika Renuka ma'am, is a professor in Department Information Technology, PSC College of Technology in Coimbatore. She is an associate dean and convener for Student Welfare Committee in PSC College of Technology. She was postdoctoral research fellow from Wright State University, USA. Her area of specialization includes data mining, evaluationary algorithm, soft computing, machine learning, and deep learning. Effective computing, computer vision. She has organized an international conference on innovation in computing techniques, a national conference on information processing and remote computing, and so reviews for computers and electrical engineering. Elsewhere, Wiley book chapter, Spring book chapter on knowledge computing and its application. She is currently guiding 7 research scores for PhD under Anna University. She has published several papers in reputed national and international journals and conferences. Over to you, ma'am.
Hello, ma'am. I'm not able to hear, ma'am.
Participants wait 5 minutes.
we can start. Yeah.
Shall I start, ma'am?
Yes, ma'am.
A little progress each day adds up to big result. Once
Yes,
again,
we can start. Yes, ma'am. Yes.
I would like to welcome our guest speaker, Dr. D. Kartika Renuka, ma'am, is a professor in Department of Information Technology, PSG College of Technology in Coimbatore. She is an associate dean and convener for Students Welfare Committee in PSG College of Technology. She was a postdoctoral research fellow from Wright State University, USA. Her area of specialization includes data mining, evolutionary algorithms, soft computing, machine learning, and deep learning, affective computing, computer visions. She has organized an international conference on innovation in computing techniques and national conference on information processing and remote computing, and so reviews for computers and electrical engineers. Elsewhere, Wiley book chapter, a spring book chapter on knowledge computing and its application. She is currently guiding 7 research courses for the PhD under Anna University. She has published several papers in reputed national and international journals and conferences. Over to you, ma'am.
Yeah, thank you for your good introduction. So, good morning, one and all present here. Let me start my presentation. Before that, 2 minutes to share my screen and check my audio and video. So, can you hear me?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, 2 minutes. I will switch on my video and I can start my presentation within 2 minutes. So. Now I'm audible, right?
Yes,
Yes,
ma'am.
ma'am.
Yes. Let me check with connect my video also. Yeah, can you please verify whether you could see me?
Screen
Yes,
is
is
not visible.
sir. Can you now please check it once again?
Yes, yes, ma'am. Yes, ma'am.
Yes,
Your audio
ma'am.
and video is very clear.
Yes. Okay. Thank you. So now we will start with the presentation. Let me share my screen.
Yes, ma'am.
So I hope my screen is now visible. Yes? Is my screen visible, sir?
Yes, ma'am.
Yes, ma'am.
Yes, sir.
Yes, ma'am.
Yes, okay. Okay, then we'll start. So I like to first of all thank the Master of Ceremony for giving me a warm welcome. And I like to also thank the organizers of Kongu Nadu College of Engineering and Technology for organizing this DPT, that is the Department of Biotechnology sponsored one-day national seminar on optimization of machine learning algorithms for better healthcare service. And the Department of IT is organizing this. I like to extend my thank to Principal Dr. R. Ashokan sir, Dr. Chairman Dr. PSKR Periyasamy sir, and Dr. J. Yogapriya Madam, Dean Research and R&D in Kongu Nadu College of Engineering and Technology. So this session, or this title of this workshop or this seminar, is need of hour, which is very much important for the current scenario, as we have known that IT and computer science sector has got technology development is become advanced more and more, and the application of that in healthcare. So to make the healthcare service better service, these type of seminar will give will thought provoke many of the users, or many of the developers or the young minds to work towards it. So it's good that we are aligning with the current need of our, and working towards the application of latest technology towards this healthcare, providing better healthcare service, right? So with this, I will just start today. My topic, I am going to handle two sessions, one in the morning session and then afternoon by 3 to 4. So which is going to be like first session, I'll be covering on the machine learning and the basics of machine learning and the evolution of that, how deep learning has come or after machine learning, and how it can be applied over healthcare service. Okay, we have a case study on how it can be demonstrated for healthcare service. That is for the morning session. And for the afternoon session, I'm handling on data handling. See, when we take a healthcare as a service, the many people or many public use it, and relying that the data they have, or health records of them, are confidential and private. Privacy is maintained, confidentiality is maintained. So for that reason, what are the technologies that can support to better healthcare service to provide security and privacy preserving in with respect to machine learning algorithms? That is what I am going to cover in the afternoon session. That is mainly on blockchain and privacy preserving algorithms. Okay, so this is how the seminar, or today's my session, is aligned with. We'll move to the session. As I said, I'm audible, right? Everybody can hear me, right? Audio and video is good, right?
Yes, ma'am.
Yes, yes. Thank you. So we will just move to the introduction. As we all know, artificial intelligence, okay, as we say, it is like which is trying to provide machine human intelligence, okay, as occupied the lexicon and of successive generation of computer scientists, and for science fiction fans, and for medical researchers. Okay, artificial intelligence, nothing but making the machine to act like human. Okay, like how we human, how we react, or how we think, how we respond, everything is what we wanted the machine also to do. For example, if I'm talking in English, it has to understand English. If I'm talking in Tamil, it has to understand Tamil. Okay, like a doctor, how he diagnoses our health issues and provides a prescription or medication. Likewise, the machine has to understand on the conditions of the patient, and it has to respond in the way the doctor provide service to the human. okay, or to the patients. Like, but that's how we are, the technology is helping now, and the researchers are all moving towards attaining that goal. We can't replace any doctors or any of the existing things, but we can provide better service with the latest technology. So that is what artificial intelligence is trying to do. And for that, mainly we have that is the two buzzwords or two keywords which is ruling the industry is the machine learning, deep learning, and the afternoon session what I'm speaking is about the security, which includes blockchain, right? So the aim of countless careers have been built. So based on these, we have infinite careers opportunity have been built. Okay, has been come to build the engineering machines that can interpret the world as humans do. Excuse me. Excuse me. Yes, sorry for the interruption. Yes, we'll continue. So based on this, we have millions of countless careers have been built, and it is making the it's building, it is helping to build intelligent system that can interpret the world as humans do, understand language, and learn the real world examples. Okay, so you can hear me, right? All of you can hear me, right? Yes, all of you can hear me, right?
Yes, ma'am.
Yes.
Yes,
So
ma'am.
these innovations, whichever we speak, okay, or whichever the innovation happen in the AI, as it includes widespread use of electronic health records, telemedicine. It involves robots and decision support for surgical procedures. Nowadays, we can find all these things coming into the role. When we speak about a medical service, it is not just a patient, doctor, and other entities of a medical system, but it and also in we have telemedicine, we have robots doing helping in decision support for surgical procedures, and we have the electronic health records of the patients maintained in centralized way. Okay, in a centralized way, so decentralized way, so that it is accessed from anywhere, from any hospitals. Okay, so the machine learning applications have been very important over the entire health sector. Okay, it can be used for improved therapeutic interventions, for augmenting workflow, data collection, processing, because we have almost the bio sensors, okay, placed in the human body, which will continuously send data, okay, over to the machine to diagnose the patient's health, and based on that, the medications and the subscriptions of the doctors could be changed over time. Okay, so and they are also used for genome interpretation, for effective clinical triage, and for streamlining drug designing. And it's also mainly used not only for surgical procedures or for maintaining electronic health records, also used for streamlining the drug design. Okay, because we know COVID has given us a way for proving that how the healthcare service is being vastly developed. with the latest technology. We were able to develop the vaccine, okay, and India was into the top leader market for producing the vaccine, okay. So all those for COVID, okay. So all these are the advancement of technologies have been applied over the healthcare industries, and that is how we could achieve that. So that is what we are also trying to do. So in that case, the machine learning algorithms play a very important role. So what is machine learning? Actually, in earlier part of the century, two events that is two events coincides and that transform the field of AI. Because earlier itself, we know what is machine learning or AI earlier itself, but the applications, how it has been applied to recent research is now become vast because of two important transformations. One is because of the GPUs, which is meant for parallel processing, which does fast, cheaper, and more powerful processing. And at the same time, the era of big data. Okay, earlier there were models which does processing only over the text, but nowadays we have the deep learning models which does processing over images, text, bioinformatics, medical records, financial transactions, and does everything from one place, okay. So and this is how we are able to make a move into a mainstream along with almost limitless data storage, and data storage are also given a good place. So these, because of the advancements of these GPUs which does good processing with cheaper and faster way, and similarly with the invent of big data, that the model is able to process the big data like images, videos, okay, and able to provide large amount of storage, okay. These were all they provided these are the factors that lead to dramatic resurgence in interest in AI in both academic circles and in industry outside the traditional computer science. So traditional computer science is just core development, okay, but we are applying computer science and IT over several applications. How why it has been nowadays become we are vastly applying these type of services by providing computer services is required for other applications because of the technology development, access to models accessing or providing access to big data, and we have good processing power to handle any type of data, okay. You think on a doctor providing doing a surgery, okay, or a heart transplant, everything is available in videos nowadays. And also we have face what is that face makers which does sense the heart and other sensors which we fix on the body, which does sense the data, and it provides some accurate informations over and based on that the doctor does the diagnosis. So how this computer science is, or how technology of computer science is being are applied over the healthcare services is what we have to understand, okay. So machine learning is one of the biggest strength of our computer science technology, okay, or IT development of technology in IT and computer science, which does many miracles over the healthcare service, okay. So that is what is machine learning. We'll understand what is machine learning, and we'll move on to know on different types of problem solving, and we'll move on to the latest development on a deep learning model, that is on convolution neural network model. This is how the today's seminar is structured. So first is machine learning. As we say, it's a study on computer algorithm that learn complex relation from empirical data and make more accurate decision. It's used to make a more accurate decisions, okay. And rather than coding a specific set of instructions like we do for a compiler or for another any type of program, machine learning algorithm, it is just it's trained using large amount of data and algorithms that it is like you model something and you train it over large amount of data, and your algorithm will now inherit the ability to learn, and it will know how to perform the task. That's what machine learning model is. The strength of machine learning is like you are like how you are how we make our child to learn, or how we make our students to learn something on about a new course and making them to develop such things, or likewise machine learning model will be made to learn on the existing data on the training set. They'll be trained on a large amount of data. So that's where the big data comes, and then algorithms will now configure or will inherit the ability to learn how to perform the task. So machine learning algorithms can be classified into two types, as we all know: supervised learning and unsupervised learning. Supervised learning is like how it's like a teacher teaching something in the class and asking the same thing in similar topics of that in the test, or okay, like in internals or in a CA test. So likewise, we will be training, so the targets are known. Okay, when the teacher teaches in the class, they explain that with the output. Okay, that is A for apple, B for boy, something like that. So they will narrate us with the targets. So when the same thing is presented in the test, the children will be able to diagnose about the or able to identify that or object, and based on the output it produces, the performance of the model can be measured. That is supervised learning. Whereas that is the data set we are training will be associated with the class labels. Okay, whereas in unsupervised learning, the model will be the targets will not be known. And how then there also we have models. How does the model learn there? It is by learning from similarities. That is like grouping class students based on whether how many are tall, or how many are short, or how many are wearing specs, like that. So it's based on similarities, based on the input. So no training happens here in unsupervised learning. As and when the data comes in, it will be assigned to the cluster or the group to which it is most similar to, and then it will be further several iteration, it will be aligned to the perfect group or perfect cluster. Okay, that is about machine learning. So one of the major advantage of one of the main important part of machine learning algorithm, we have different machine learning algorithm like naive bayes, decision tree, SVM, okay, knn. So we have so many algorithms and machine learning models, and the very important part of that, which does the magic of what we are speaking in healthcare, is on artificial neural network, which from where the deep learning has got its root. Okay, so there are, and as I said, as I now start with ANN, it is not like all other models are not useful. It is all useful. Deep learning model is one of the latest advent, which has got great attraction towards current trend. But all other models like naive bayes, SVM, KNN, okay, and the clustering algorithms, k means, everything is addition tree algorithms, everything has its own history and got is powerful on certain applications. Okay, so today's session we will move on with the basics of what is artificial neural network, how deep learning is evolved from artificial neural network. So artificial neural network are one of the group of algorithms is used for machine learning. Is one of the machine learning algorithms. That's all. So while ANNs have existed over 60 years, they fell out of favor during 1990s and 2000s only. Okay, because the last in the last half decades, ANN has a resurgence under a new name because of deep learning. Okay, we know that artificial neural networks have evolved over many years, and it is not got attraction over some time because of the complexity of the models that is involved, because we know the complexity of a neural network model will be very high, and it takes more hours to develop and to test and train the model. In such cases, that was not being used by many of the researchers. But nowadays, the things, because of the advent of GPUs and because of the big data applicability of models over the big data, images, videos, speech, deep learning models have become more attracted, and ANN has now are uniquely poised to take the full advantage of computational boost offered by GPUs, allowing them to crunch through the data sets of enormous size. Okay, and the applications vary from computer vision, so image classification, object detection, face recognition, OCR, natural language processing, and even game playing problems. So it's span across all disciplines. It is interdisciplinary technology which is used over interdisciplinary research. Okay, so that's how we must understand how machine learning and ANN has got what is the strength of these technologies under computer science. And now and it is in healthcare also, it's been majorly used. So generally we'll start from basics. We can say the problem solving techniques can be of two types. One is hard computing or soft computing, where hard computing it deals with some precise models, which is traditional numeric modeling and for symbolic logical listening. And soft computing actually it's what we are speaking about on neural network. It provides approximate reasoning and provides functional approximation and randomized search. So what is all possible in soft computing is like soft computing techniques, as we say, it is not just neural network. We have optimization technique. The title of today's workshop is on optimization on of machine learning algorithms. So all these machine learning algorithm, as I said, the SVM or the naive Bayes or KNN or decision tree, for that we can provide an optimization algorithm towards it. So what is optimization algorithm is also a soft computing technique. It involves natural inspired systems like neural network, fuzzy logic, and swarm intelligence, and the computational time required is less, and it involves intelligent computational steps. Outcome of the soft computing is stochastic or random in nature and need not be deterministic as like in hard computing. And soft computing, it deals with ambiguous and noisy data, which is the real world data, whereas the hard computing, it requires only exact input data. Okay, so this soft computing, it does parallel computation, and it does, whereas hard computing, it does only sequential computation. And finally, the soft computing techniques produces appropriate answers, whereas the hard computing, they provides the precise answers. So you must understand where is our machine learning model fitting in. It is in the soft computing technique, which does where you can add the optimization also, which is that used for real time solving real time problems. So its a main idea is to make the computers to act like human. So for that we have to understand how a human brain functions. So you know what is the functionality of a brain. So before that, how the mapping of the human of a neuron is mapped to an artificial neuron is what we are going to see. The above structure is what the structure of a neuron, which is a biological neuron. Okay, you must have known this diagram in 12th standard biology book. So now it is mapped over to an artificial neuron. So we have the input is passed over the input layer, and the connection between the input and the middle layer or processing layer is done by the dendrites. So dendrites, and then we have the cell body which does the processing, and from the output we have axon. So same way in biological neural network, we have the nucleus, from where the one nucleus is connected to another nucleus by axon, which takes the output. And we have dendrites also, which carries the information from one nucleus and provides the connection from one nucleus to another nucleus. Okay, so this is just a mapping of a biological neuron to an artificial neuron, and this is the computation of how the brain is. So brain consists of 10 billion nerves. So this is only one neuron. Okay, likewise our brain has 10 billion nerve cells or neurons, and each neuron is connected to another neuron, approximately 10,000 synapses. So we have only one synapses which is laid here, but likewise we have 10,000 synapses. So you must understand how complex the structure of our brain. So are we all gifted having such a big complex structure in our brain? Yes. Yes, it's obvious. It's God's gift that we have got such a big mystery. Brain processing of brain is still a mystery. Okay, it is not just developed by anybody. It is the God who has developed this, and AI is now moving towards making the machine to act like our brain. Okay, So it does stimulation for the similar type of number of neurons with so much connection, so that the processing power of the computer will be similar to that of brain, and it does good processing like our brain. So this is what the artificial neural network is. So as I said, the inputs are passed to the input layer. We have three layers here. Artificial neural network, when we wanted to define, we have three layers: input layer, hidden layer, and output layer. Input layer is where we pass the inputs, and from the input layer we have the connections. Okay, links, weights. We term that as weights, that is used to connect the input layer nodes to the hidden layer nodes, from hidden layer nodes to the output layer nodes, and the output layer nodes produce the output. Okay, so this is the structure of a basic artificial neural network. We'll study more on what is artificial neural network. As I said, example, a definition is: artificial neural network is an information processing system with an highly interconnected processing elements or units that stimulates the behavioral aspects of biological neural network or a brain with certain assumptions. So it does a similar processing. It is going to stimulate the processing power of a human brain. It's an information processing system. Okay, like our brain is is a biggest information processing system. It does numerous information processing parallelly. Okay, by the time I'm taking the class, you must be doing parallelly many of the activities, as we all are humans who are flexible enough to do parallel processing, right? So artificial neural network, likewise, only we are making the machine also to modeling. We are trying to model the machine also to be to do such things like human. Artificial neural network is like, we have the input vector, hidden layer, as we already said, it has three layers: input layer and the hidden layer and the output layer. And basic assumptions of an artificial neural network is: the information processing occurs at simple element called as neuron, and here the signals are passed over the links which are connected, associated with some weights, and each neuron applies an activation function. So we have an activation function which we'll study later. So activation function is used to determine the net input and determine the output. And what are the characteristics of an artificial neural network is like, we have the characteristics of artificial neural network is depend upon the architecture, on the training or the learning that we apply, and on the activation function. Okay, so this represents the different types of architectures of an artificial neural network. So we can employ any one of these type of artificial neural network to our application. And this is it can be a single layer feed forward network, or a multi-layer feed forward network, or a fully recurrent neural network, or a competitive network, Jordan network, or simple recurrent network. Any of these models can be employed. And coming to the learning types of learning, already I've said. So supervised learning and unsupervised learning is like providing the network with series of sample inputs and comparing the output with the expected response. To supervised learning, that's training the model with the known targets. Whereas unsupervised learning is like, most of the similar input vector is assigned to the same output unit, that is based on similarities. It learns by model learns by the similarities. And finally, the reinforcement learning. In this case, the targets will not be directly known, but the indication whether the answers are correct or not will be known for making the training, or to making the model to move towards the target. That is reinforcement learning. Okay, so we'll move to the development of ANN. So first we had the first generation of ANN, which is called as MC Cloak Spitz threshold neuron, which is developed in 1943. So first generation of artificial neural network, it developed in 1943 itself. So it was before a decade. And second generation of artificial neural network was developed, which involves several algorithms like perceptron, backpropagation, coconut neural network, radial basis, adaptive resonance theory, Hopfield network, and SVMs. And then they had a third generation of artificial neural network, which is nothing but the spiking and pulsed neural network. Okay, so with this development, after this also it is evolved. Now we are in the peak tower of artificial neural network, which can take any input of any form, and does the processing and provide optimization over it and provide good results. Okay, and it applies over real-time data also. So first we'll learn from the basics. So first first type of neural network is MC clock Spitz neuron. So this is the simplest of all the model, and it was the first model which was developed by Walter Pitts in 1943. And as we see here, it is like inputs x1, x2, xn is given to a neuron and produces one output y. Okay, that's all. And next neural network is the perceptron. So perceptron is like, it is an improvement that we added to the MC clock Spitz network. Here it is a linear classifier and performs binary classification. This has a single layer, that is one input layer and only one output layer. So it's a single layer feed forward network. Single layer is referred as output layer, and input to the perceptron is vectored with real values with zeros and ones. So it is just a perceptron. It is like inputs connected to the processing is by weights, and finally y is the output, and we apply activation function over the net input and we get the output. Okay, so this is just to make the non-linearity activation function. Role of activation function is to make the non-linear data to linear data. Okay, what type of activation functions are available in general? We have sigmoid function, hyperbolic tangent function, and ReLU activation function. Over this we have softmax activation functions also nowadays becoming popularly used in deep learning models. And coming to multi-layer perceptron, so multi-layer perceptron is like multi-layered graphs have layers. So it's like not just only one layer, it has many hidden layers. So it's multi-layer feed forward network. Okay, so this type of network with information flowing from one end to another end in one direction through is called as feed forward. It's a multi-layer feed forward network, and the nodes in the hidden layer and in the output layer and are processing units which does non-linear activation functions. So here in the case of perceptron, there was only one input, and the output input layers are connected, and the net input is processed over an activation function to produce the output. Whereas in multi-layer perceptron, we have many number of hidden layers, and these hidden layers are called as processing units with a non-linear activation function. It is the place where the processing happens. So this is how our brain is also structured. Like there's got n number of hidden layers which does processing of inputs and provides the output. And this is actually what type of optimization technique is used in this used in this neural network is, yes, we are employing a very important type of activation function called as gradient descent activation function, so optimization function, which is used here for providing optimization for your output. So difference between the actual and predicted output will be termed with error factor, and after that error factor is our objective is to minimize the error factor until the error is become less. We have to iterate the model, or we have to make the model train, and once the error is over, or error is minimized, or error factor is very small, we can omit it, and we can say the network model is converged. So the basic optimization algorithm model which is used in neural network is the gradient descent optimization algorithm. This is the simplest optimization algorithm used to minimize the error function. It was invented by Koski in 1847. And the basics of this gradient descent is defined. Okay, you can learn it separately, and main objective is that to minimize the error. Okay, and we have the error function which is also termed as loss function. See, this is one of the important metric that we use to evaluate any model's performance rather than just accuracy, precision, recall. We also will nowadays the researchers also always verify with the loss, entropy loss, and the and other losses which is going to be useful to determine the performance of the model. So cross entropy loss is the model is used for most of the classification models use this cross entropy loss for evaluating its model's performance. So as we said, the neural networks has now applied over multiple disciplinary. It is used in neurobiology, cognitive psychology, linguistics, philosophies, economics, where you have economics of finance, where you have the time series or data mining uh,
streaming data. It is also used in engineering, which does image signal processing, and for controlling theory robotics. And it's also used in physics, dramatical systems, statistical physics, and it's also used in mathematics, and also used in computer science. So it is a multidisciplinary view of neural networks. So now coming to deep learning. So understanding the convergence of how AI, machine learning, deep learning, and all are related. Okay, so it's AI is a overall is a big set. Machine learning is a subset of AI, and deep learning is subset of machine learning. Okay, so you must understand this in a very good way. So we are our objective is on the title of webinar is today's webinar is on optimization of machine learning algorithms for better healthcare services. So where is that machine learning? It is a subset of AI, which is going to make the computer to mimic the human intelligence. And in under machine learning, one of the famous algorithm that we are studying is on neural network. So neural network has got its rebirth after the advent of deep learning. So we are now going to know about what is deep learning. Okay, and later how it is applied over healthcare services with a case study, right? So how this machine learning and deep learning are varied, okay, how they are different. As we said now the current real time data, it does not deals with just text or numeric data. It deals with images, video, audio, and all the test reports that we generate over the healthcare services, EEG, EMG, or whatever blood reports, everything is now digitized. Okay, so all those digital data can be is not just numeric data. We have videos, we have the images, okay, we have the time series data. Those normal machine learning models will not be able to process all those types of input. Okay, so that is the main reason of why deep learning has become popularly used in healthcare services. And because it is now going to process any of your time series data, any of your image, or any of your video, or any of the numeric and text data also, right? So in respective of whatever data is, it does, because why it is able to handle it is the model that we are developing will do feature extraction, and then classification is done together. Whereas in normal machine learning algorithm, the feature we have to employ some steps for feature extraction, and then only apply a classification model or a clustering model over the input. So this is where the difference between machine learning and deep learning is and that's the reason why deep learning has become popular nowadays. And the basics different there are different deep learning techniques, which is normally becoming more popular. Their convolution neural network, recurrent neural network, and LSTMs, autoencoders, and RBM, that is a restricted Boltzmann machine. So today's session we will start with convolution neural network, and we have a case study on how it's applied over chest x-rays of COVID patients. So basics of convolution neural network. Till now, did questions or queries you have, you can please ask me. I'll pause for 1 minute here, and I'll get to know how the session is, and can we proceed further? You please let me know. Yes? All are comfortable? Yes or no, please respond me. Any one of you can respond me. Anything is comfortable, able to follow? Yes?
Yes, ma'am. Yes, ma'am.
Yeah. So we'll now move on with the basic convolution neural network model. Yes. So convolution neural network model, as I said, it's a deep feed forward artificial neural network. Okay. It's a neural network. Okay. And how it is different from a normal neural network, from a normal backpropagation or a perceptron neural network. It's what we are going to study, and how it's applied over a healthcare service is what we are going to study in next 10 to 15 minutes. I'll just move faster. If you have any doubts, you note it down, and I'll clarify you at the end. So CNN is like a neural network. It's made up of neurons with learned weights and bias, and it has input layer, hidden layer, and output layer, as we all know. And what is difference between a normal neural network and a convolution neural network is like the normal neural network is inspired by the artificial neuron of a brain. Our processing of a brain is what artificial neural network is. Whereas the convolution neural network, it is inspired by the visual cortex of a human. Okay, visual cortex is different from the human brain. So it's like the architecture of convolution neural network is analog to that of the connectivity pattern of a numerous neurons in human brain, and it is inspired by the organization of the visual cortex. Visual cortex means, see, it's not like, it is not just the structure of the human brain we imitate. It is just going to be, is inspired by the organization of visual cortex. Cortex in the sense eye. So whatever we see in the eye is the input for our brain, right? So you imagine that we have a complex structure like how we like this. We have a complex structure like this, okay, in our brain. So our brain is such a type of complex structure. So the input of this is not just the input you pass to the input layer. The input you pass to this input layer is now got from the visual cortex. Okay, that is what the CNN does. So input for this is a visual cortex, that is what we see. Okay, is presented to our brain, and then the brain the feature extraction it does on the images or the videos or the scene that we see in front of us, and then it processes it and provides the output. So that's what convolution neural network is. Okay, so we are not going to process any of the image or video or a speech blindly as like input layer. We pass it and over to the hidden layer and then to the output layer. It is not happening like that in a normal, like in normal neural network. It is like inspired by visual cortex, like how we whatever we see in our human brain, human eyes. Okay, visual cortex, it is presented over the brain, and then that is and there the importance for what we see is identified. Feature extraction is identified. Our eyes itself will get some attention on the object that we see in front of us and able to recognize it. So that's what the same thing we do in CNN. Okay, it does feature extraction and of the object that it sees or is presented with, and it passes over to the backend neural network, and it processes the and provides the response, like how we are able to identify the object which is presented in front of us. Okay, so the role of convolution neural network is reduce the image into a form which is easier to process without losing its features and making a good prediction. And the objective of convolution operation is to extract high level features such as edges, images of the input image. And how it does that, it is by all these layers. So we have four important layers. The last layer is what a traditional neural network is. Before that, we have three important layers. One is convolution layer, pooling layer, which is otherwise called as downsampling layer, and flattening layer, and then fully connected layer. Okay, the fully connected layer is what a normal neural network is. Next is first we'll study about convolution layer. So convolution layer is something like it's like CNN in neural network is with any number of convolution layers you can employ. What it does a convolution operation over the input image by number of filters. So what is that filters will have? Will have the weights. So we have the weight parameters stored in the filter. It can be 2 cross 3 cross 3 or 4 cross 4 filter, and we are going to apply a convolution operation over the image, input image, and the filter, which filter is otherwise called as kernel. Okay, so the convolution layer, what it does convolution operation between the input image and the filter, right? And what does the filter have? It has the learned weights. And convolution is done by computing the dot product between this input matrix and this filter. So we are going to just make a dot product of this input matrix. So same thing is presented. We are going to apply this filter over the input image, perform a convolution operation, which is nothing but the dot product of that input image and the filter learned weights in the filter or the kernel. And what is the output that we get? It is nothing but a feature map. So feature map is the output that we get of a convolution neural network. So it is controlled by three important parameters, namely depth, stride, and zero padding. And we'll present an example you can understand. So this is how. So stride 1 means the input filter is passed over the input image over one stride, and whereas stride 2 is presented like the input image is passed over the filter is passed over the input image with two columns. And padding is nothing but to make resizing the image perfectly fit the kind of filter is what padding. And we have pooling and downsampling layer. It is like for dimensionality reduction. So when we apply this convolution operation over a image, input image in the filter, sometime you will make the image size go bigger. In order to make it dimensional reduction, we apply this pooling or downsampling layer. It is progressively reduce the spatial, so it is going to reduce the what is that, it's going to make the dimensionality reduction without without loss of information, or without affecting the performance of the model. So pooling layer is to progressively reduce the spatial size of the representation to reduce the number of parameters and the computation in the network, and it controls overfitting, and it's otherwise called as subsampling or downsampling, and it is mainly used for dimensionality reduction. So the same information is presented, but the dimension of the data is reduced, subsampling. And we have different types of pooling. One is max pooling, average pooling, and sum pooling. And next we will study about them later. Flattening layer. So finally, third layer of a convolution neural network is a flattening layer. So in the flattening layer, what it happens is like we are now going to the next. We are going to present the input features that we have extracted over an image or a video or a speech or whatever it is, to a normal neural network, to the backend neural network, as I said, to get the response, right? So for that, the input, we know the traditional neural network will not able to handle any big data. So for that, all the data has to be flattened, okay, into a one dimensional data. So the fully connected layer, as we know, it will not process the multidimensional data. The feature extracted by the convolution layer and by downsampled by pooling layer has to be flattened, and that is done by flattening layer. So now that this data should be reduced down to single dimension for each channel before processing. And now the data is now fed to a normal fully connected layer, which is nothing but a multi-layer perceptron, and also uh, which is nothing, which is got input layer, hidden layer, and output layer, like in traditional neural network. Okay, and the activation functions here is can be any type of activation functions, like we studied ReLU or tangent or sig model. And what, but the final it also the final layer employ final dense layer of the multi-layer final fully connected layer must employ a softmax activation function if it is case of a classification problem. Okay, so that is how we structure this convolution neural network. So you must understand what is you have known about what is a neural network. So it is in the back end. In the front end, it's like like how we convolution neural network is nothing but like how we see something in our eyes and make a recognition or response on what object we see. Convolution neural network, it does processing for all type of images. It does feature extraction, and the extracted features are downsampled or dimensional subsampled, or dimensional reduction is applied over pooling layer, and then it is present flattened over as a single dimension data and presented to a fully connected layer. Okay, so fully connected layer is nothing but the same type of multi-layer perceptron as what we studied earlier, and any type of activation functions you can apply. So in order to understand this convolution layer operation better, I have some examples. So I'll just quickly move on to this. So this is how the input image and the filter, when we apply filter over a convolution operation, first our layer is convolution layer, so which has convolution operation between the image and the filter. So it's with stride one, it does all these feature extraction. With stride two, and it can finally arrive at the feature map. So this is the feature map or with one filter. Likewise, we can employ any number of filters. So with filter 2, this is the another, so repeat this process again, and we again generate one more feature map. So this is how the features are extracted. Now you see the dimensions of the image is now become huge. For this only, this is the feature map, which is much bigger than the actual image size. So we apply dimensionality reduction over this. So the input image is 6 cross 6, but we have finally 2 into 4 cross 4 matrix of the features, which is represented in the feature map. And finally, if it's a RGB channel, okay, you can employ three each of the color image in one of the as one of the input image, and apply filter over that, and represent that for feature extraction. So this is how you generate. So when we see this, it is different from a normal neural network. How it is different is, it is not just all layers are connected like in a normal neural network. Each and every layer is connected to every other layer in the hidden layer. It's not like that. It is only few layers are can only connect to 9 inputs. It is not fully connected. So fewer parameters, and similarly we can say shared weights, even few parameters. So it is not fully connected. Okay, that is what we have to understand. Next is like same thing what we explained is demonstrated with an example. So input size is 6 cross 6 with passed over a filter of 3 cross 3 our, and after we apply a convolution operation, we'll get the feature map, and applying the downsampling or a pooling layer. Okay, max pooling layer. So maximum or max pooling layer is maximum of this is going to be retained. So 0 will be retained here, 3 will be retained here, and here again 0 1 will be retained. So this is the dimensional reduced feature set, and this is applied over the convolution. So any number of convolution or max pooling layers can be employed, and finally the new image is flattened and passed over the fully connected layer. Okay, so this is how the code snippets of this same implementation of convolution neural network is presented. So this is for your reference. I can give this for your reference later. And so we have several case studies which is to learn with, to as a beginner, to learn with a convolution neural network. You can try to implementing the image classification problem over a CIFAR data set. It's a 10 class problem, and we have applied got the good results. Now coming to the case study on how these models are applied over the COVID-19 chest X-ray images, or how it is applied over healthcare services, is what I want to demonstrate to you. So we are aiming at pre-processing the CT scan images. So you will understand it is just not the numeric values that you feed to a neural network. It is a CT scan image of a chest that is used to predict the patient is diagnosed with COVID-19 or not, is what we are going to do. And the goal is to improve the communication with the finding and serve as a potential guide in determining the need for medical guidance uh, uh, for diagnosis of COVID-19. So bacterial and viral case of COVID-19 usually results in the similar symptoms. Some causes associated with the classic but non-specific clinical characteristics, and we are aiming to apply the deep learning models over the field of medical science and make it use this concept to touch the new horizons in medical diagnosis. Yes. So the problem statement is to overcome the classification accuracy, or to improve the classification accuracy of a chest X-ray. Okay, so existing system, it does COVID-19 chest images. They apply a grayscale. So in normal method, the image is converted to a grayscale image, and it is applied over a classification model to which does COVID or non-COVID diagnosis. Okay, now CT scan image is tough to predict. So existing system is providing only very low accuracy. So we move on to a CNN based model, deep learning model, for predicting the CT scan images for predicting the COVID-19 things. Okay, so CNN, as we all know, it's a main evolution of a main part of deep learning algorithm, which can take input, and it can assign importance to various aspects of objects of the image, and to be differentiated from one another. So architecture of the convolution neural network, as we know, it is analogous to human brain. It is inspired by the visual cortex, and we'll now see how CNN is applied over this CT scan images. As we as already studied, CNN is equipped with convolution layer, max pooling layer, flattened layer, dense layer, dropout layer, and fully connected layers. So proposed system, it is like it overcome all the disadvantages of the existing system. System has provided a good accuracy over the images of CT scan, and performance of overall classification is in the is like it is able to provide you a good prediction over CT scan images. So this is the design of the proposed system. So first we collect the input, and we pre-process, provide segmentation, feature extraction, classification, prediction, and then results. So for data selection, we load the images itself over the model, and then this is the code where we employ CNN for feature extraction. Okay, so we are for this is nothing but the code snippets of how we from where we loaded the image, and then we added convolution trees. In this example, you can understand we had two convolution layer, one max pooling layer, one convolution layer, one more max pooling layer, and then flatten layer, then two dense layer. Okay, and finally we have evaluated the performance by using cnn.evaluate, and it has got good results. Okay, and data pre-processing is applied over this for resizing the image. Okay, and then finally segmentation is applied for it's a pre-processing technique. Okay, it's for making the image better, so that it is then after that from segmented data we apply the feature extraction by using a fuzzy inference model. Okay, and then finally we applied a CNN model for classification, and we evaluated it with the result accuracy, and we find that the accuracy of the things are moving good. Okay, it has got 80 to 90% accuracy on prediction of this COVID-19 chest images. Okay, over CT scan images. So I have come to the end of the session. Like in this study, we were able to, in the case study that we have analyzed, we are able to understand on multi-layer fractional order machine learning classifier has been used to rapidly see any lung lesions in bilateral lung zone, and screening process is consisted of 2D FOC, that is, and a flattening process with pattern reconstruction with IFS, and pooling process and a GRA based classifier, and then IFS we employed a fuzzy system also for pattern recognition. And finally we can say the AI and artificial intelligence and machine learning has numerous potential to transform the healthcare and practice of medicine. While innovative technologies advances plays a critical role in the rapid diagnosis and management of diseases, the phenomenon of technology imperative deserves special consideration among the public and the providers for future use of AI ML in delivering good healthcare services. Okay. Yes, and this is the book you can refer for your reference. This is authored by us, and it is and we are published over with Wiley Publications. You can and it's got some good case studies on basic fundamental algorithms involving deep learning. So you can use this as your reference to start with learning deep learning. So I have come to the end of session. I hope I have shared enough things with all of you, and any queries you have, you can please tell me, and over to the MC on analysis on the session. On any queries you have, you can please ask me. Yes. Yes, we'll
Thanks,
continue.
ma'am. Thanks to join with us, ma'am.
Okay, yes. Yeah, thank you, Kavya. Any queries we can discuss, otherwise we will leave and we'll resume back by 3 for my next session on privacy preserving on electronic health records using blockchain. Yes, thank you, Kavya. Can we leave now?
Yes, ma'am. Thank you, ma'am.
Yeah, thank you.
Feedback form will send at end of the session. Participant, the next section will be start at 2 o'clock. Thank you.
Thank you, ma'am. Thank you so much.
Yes, sir. Thank you, sir. Thank you.